right, there we go. Okay. You know, we're not going to figure out what theta is. All right. Now, also here I didn't write it, but we are assuming theta is between 0 and 90 degrees. You know, so in other words, we're only dealing with right triangle trig. I mean, you could generalize the trig functions beyond that, but I didn't do that in this class. Okay, now, okay, so what we want to do now, right? We want to make a right triangle so that this is true. Now you could work with cosecant directly if you wanted to. You know, you could do that if you want, but you don't have to though. We know that cosecant is 1 over sine of theta, right? So what this is really saying then is that 1 over sine of theta equals 9 over 8. 9 over 8. And I did show this before, but when you have something like this and you want sine of theta, I mean, it does boil down to cross multiplying, but essentially you flip both sides. I mean, I guess to show this precisely, you would have to cross multiply, but you could think of this as flipping both sides. So on the left, you would have sine of theta, you flip this, but you have to flip this side as well to get 8 over 9. So we have sine of theta is 8 over 9. Okay, that's good. Now what do we do? Well, we have our we know from SOHCAHTOA that sine of theta is opposite divided by hypotenuse. It's opposite divided by hypotenuse. Okay. And we have our right triangle. You know, this is what the sides are labeled. Here we have the 90-degree angle. This is theta. Okay. The hypotenuse is always opposite the 90-degree angle. OPP, which stands for the length of the opposite side, opposite theta, that is. This side here is next to theta, so it's adjacent. ADJ stands for adjacent side, the length of the adjacent side. And hyp is the length of the hypotenuse. So OPP, so basically here we have sine of theta is 8 over 9, right? So we're going to let OPP be 8, and the hypotenuse, we're going to let that be 9. Because again, sine of theta is opposite over hypotenuse, and that's equal to 8 over 9. You want a right triangle where this is happening. So we set the opposite side to have length 8, and the hypotenuse to have length 9. As you can see, right? And you know, if I gave you this triangle alone and I said, what is sine of theta? Well, that's opposite over hypotenuse. So we're good. But we don't know what this side is, right? How do we get that? Well, Pythagorean theorem, right? You have two sides of a right triangle. How do you get the third side? Pythagorean theorem. At least in this case, if you don't know any of the angles, so except the 90-degree. You know, we don't know exactly what theta is, and we don't know what the other angle here is. We only know the 90-degree angle. So we have to use Pythagorean theorem. So I'm going to call this x down here. That's the length of this side. Right? So we have x squared, excuse me, we have 8 squared plus x squared is 9 squared. You could write it as x squared plus 8 squared equals 9 squared. Essentially, you'd be interchanging 8 squared and x squared. That is, you're adding them the other way around. But that's okay, because addition, you can add two numbers any way you want. So we get 8 squared is 64. Wait, let me say it again. So from Pythagorean's theorem, we have 8 squared plus x squared is 9 squared. 8 squared is 64. X squared is just x squared because we don't know what x is. 9 squared is 81. What do we do next? Subtract 64. Right? We want to get x all alone. So by subtracting, we get x squared equals 17, right? But we don't want x squared, we want x. So what do? We take square roots. So this side here is the square root of, the length of this side is the square root of 17. Are there any questions on that? All right. So once you get all the sides, you're essentially done. You just use the definitions. You use SOHCAHTOA and the reciprocal identities. You know, we know what sine and cosecant are. Cosine of theta is adjacent over hypotenuse. So that's radical 17 over 9. Okay. We know, so secant is 1 over cosine, meaning you flip this to get 9 over radical 17. Tangent of theta, that's opposite over adjacent. So that's 8 over radical 17. And cotangent then is just 1 over tangent, meaning you flip this. That's all it is. So, are there questions on this? Okay, so I don't know if we'll finish this one, but we could definitely start it at least. Let's suppose this angle here, theta, I'm telling you that it's 50 degrees. Okay, I'm also telling you that this side here is length 2, right? So we know an angle, and besides the 90-degree angle, and we have the length of a side. We can get the length of all the other sides. You know, we can get the length of B, and we can get the length of C. You know, we can do that. Okay, and we can also find C without using B. I know theoretically you can use Pythagorean's theorem, but you know, this is trig, so let's use trig functions. So how would you find B? Well, you have to figure out what trig function you're going to use. So B is the opposite side, right? B is our opposite side. A is the adjacent side. Hope you can read that. C, of course, is the hypotenuse. That's always, you know, the case because it's opposite the 90-degree angle. So here for B, we have opposite, right? We know the adjacent side, which is 2. So we would have to use tangent, right? Opposite, adjacent. For that, we would have to use tangent. That's what we would have to use here. Now, see, we're not going to get much into this, but once we do find C, though, we would have the adjacent, and C is the hypotenuse, adjacent, hypotenuse. So to get C, we would have to use cosine. Okay, see, I think we're out of time now, actually, so we're going to have to stop here. Okay.